Now we begin the biggest section in this chapter, which is section C, stationary points of functions of two variables. Okay? In this first video, I will do a reminder for one-dimensional functions. So when you have a function f of x, let me draw this function. Let me draw it like this. Okay, this is a function f of x. So you could find local maxima and local minima. And the local maxima is here. You have a local minimum here. And what they have of special is that the derivative is equal to 0, because the slope is 0 at these points, right? But you also remember that you also have inflection points, such as this one, yeah? Where the derivative is also 0, and yet it's not a minimum and it's not a maximum, yeah? And this is called an inflection point. And do you remember how to find these points? So first of all, you have to solve the equation derivative with respect to x equals 0. And this gives you the stationary points. Which in this case would be these 3 points here, because they have a slope of 0. And then you had to determine if this stationary point was a maximum, a minimum, or an inflection point, yeah? And the way you could do this is, that is, you have to calculate the second order partial derivative. Sorry, the second order normal derivative, yeah? So you have to do d squared f with respect to x squared, okay? And if this was positive, this means that the derivative of the derivative is positive, which means that the derivative of the slope is positive, which means that the slope is increasing. So if the slope is increasing, it means that this is a minimum, because the slope was negative, it becomes 0, and then it becomes positive, okay? So then this means that this is a minimum, local minima. Local minimum. Now if this second order derivative was negative, this was a local maximum. And then if this second order derivative was 0, then you were not sure what it was. It could be an inflection point. It also could be a local maximum and local minimum with 0 second order derivative. So this would mean that we need to further study. Okay? So this is what you did for one-dimensional functions. So in the following videos, we're going to apply the same thinking to our two-dimensional functions. So see you in the next videos.